And I hope you're having an amazing day and welcome to another episode of 10 p.m. University. So today will be the last episode of Math Week. So we're going to talk about factorials. So I want to end this week with factorials, then we're going to talk about another topic, right? Okay, so let me give you a brief history before we jump into some problem solving with factorials. So multiple scientists, right? They worked on factorials, but the principal inventor name is J. Stirling in year 1730, who gave the formula after some work on collaboration with de Moivre, then Euler in 1751. And finally, Christian Kramp, who introduced between 1808 and 1816 the actual notation that is represented as an explanation. The factorial, right, is the continuous product of an integer, right, and the subsequent values less than n. It's expressed with a sign of explanation, which you can see that here. So it will be written something like this: n times n minus 1 times n minus 2, and so on, right? So where n, this is you can also call it as n factorial, right? Factorial value of 0 is 1. That is 0 factorial. That's equals to 1. The factorial values for negative integers are not defined, right? So let's do some exercise so it will become clear for you. So today's session is very short, so I won't take much of your time. So just give you a brief introduction of how the factorials works, right? Okay, so let's do a very simple problem here. So the problem number 1. Right, so let's calculate the factorial of 6, right? So this can be written as, if you go by this logic, 6 times where n is 6, n minus 1, that's n minus 1, 6 minus 1, 5 times, then 4, then 3, then 2, right? This can be written as, so this is something you can also write, or you can also write 6 factorial equals to 6 times 5 factorial. It means the same, right? So this will still become something like this, 6 times this, right? So that's one of the way you can actually do that. So let's work out some problems here. So you can multiply 2 factorials. That's possible as well, right? So let's say you have something called 3 factorial times 4 factorial, right? So this can be simplified in a very easy way. So let's work out for the 3 factorial first. So 3 times 2 times 1, because we're doing n times n minus 1 times n minus 2, right? So this equation here times, then we're going to work out for the 4 factorial. That's 4 times 3 times 2 times 1, right? And this going to equals to 6, right? Because it's 6, and this is 12, 24, right? So this will be equals to 144, right? So this is something you can do. And let's do one more example here. So we're gonna do 5 factorial times 10, right? So this can be written something like 5 times 4 times 3 times 2 times 1 times 10, right? So that could be something equals to 20 times, so this is 6, so that will become 120, so it will become 1200, right? So this is the one way you can do that. We can do other example as well, but for now this is enough. I think you got the hang of what I'm trying to do, right? Okay, so we can divide 2 factorials as well. So let me clear this off first. Then we're gonna look at division of 2 factorials. Nice and simple. So yeah. Just a second, let me clear this. just won't take longer. I'm just gonna do this, and then we're gonna do division. Right, okay, alright, we're gonna do the division now. Okay, so let me change the type to pen. Okay, right, so we got example like for let's say you gotta calculate workout 4 factorial divided by 3 factorial, right? So this could be written something like this: 4 exclamation, 4 factorial, 3 factorial. So this equals to 4 times 3 times 2 times 1, 3 times 2 times 1, right? So you can cross this off, 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 cross this off. So it will become 4, right? Nice and easy. Okay. So similar to addition, you can. So this is how you can do. You can take any number, right? You can do 10 factorial divided by 5 factorial. This is something equals to 10 factorial divided by 5 factorial. So this equals to 10 times 8 times 10 times 9 times 8 times 7 times 6 times 5 factorial, 5 factorial. So I just got a cross away, so it will something like 10 times 9 times 8 times 7 times 6. Yeah, you can work out the answer by yourself, right? So that's how you can do. Then we can do addition of 2 factorials. That's pretty straightforward. So let's do something 6 factorial plus 5 factorial. So this will become something like 6 times 5 times 4 times 3 times 2 times 1, right? Plus 5 times 4 times 3 times 2 times 1, right? So this will become something like 120. So this is 30, so something like 720. It will become 840, right? So this is how you can add 2 factorials. You can divide 2 factorials, multiply 2 factorials, then we can even subtract 2 factorials, right? So we're gonna do subtraction of factorials now. Let me clear this off first, then we can deal with that. I hope you find this session a bit easier. Factorials are not difficult if you understand the concept, right? It's pretty easy to do, as you can see, right? So it's pretty basic maths. It's not complicated. Okay, so let me clear this off, and then we're gonna. Okay, all right. I think that's enough. Okay, so what we're gonna do? We're gonna do subtraction of 2 factorials. So let's say we're gonna subtract 8 factorials minus 5 factorials. So this could be written as a very simple way: 8 times 7 times 6 times 5 factorial, right? Minus 5 factorial. You can do something like this, right? Because 8, 7, 6, 5, and you can, so, and this implies, so this will become something, so you can take the 5 factorial out, and then you have 8 times 7 times 6, right? And then you have minus 1, right? So you're gonna have 5 factorial times, this would be 36, so 336 times 335, right? So this will be 5 times 4 times 3 times 2 times 335, so that's equals to 120 times 335. You can work out how much it is, right? So that's how you can subtract it. So you can do more if you wanted to do, right? So this is very easy stuff to do. So now what we can do, so similarly you can, there are a lot of different examples here, like for instance, what happens if you get a problem something like this. 11 factorial minus 10 factorial over 9 factorial. So you can do that. So here you will apply the subtraction logic, and in total you will apply the division logic, right? So this could be written something like 11 times 10 minus 10 factorial. So 10 factorial, right, over 9 factorial. This could be 10 factorial 11 minus 1 divided by 9 factorial, right? So this will be 10 factorial times 10 by 9 factorial. So this will be equals to 10.9 factorial times 10 divided by 9 factorial. So this will be equals to 100, right? Because 9 factorial crossover, right? So this is pretty easy example, right? So now we'll do one more problem, and then I think we will close for today, because I think that's pretty much I wanted to cover today. But there's one more exercise I wanted to do, right? Because I wanted to make it very simple and nice, right? So the 4 things I wanted to talk about: add, subtract, multiply, divide, with respect to factorials. So we're gonna do one more exercise, and then we will close it off for today. Right, okay, just a second here, let me clear this off, right. So this is like a high school math. I mean, it's pretty straightforward, it's pretty easier. I mean, so it's not a complicated mathematics at all. So you will learn probably in year 8 or year 9 or something. I vaguely remember what year I've learned, but yeah, okay. All right, so what we're gonna do, so we have this numbers like 5 times 6 times 7 times 8 times 9 times 10. We need to convert this into a factorial form, right? Now, look at this problem for a second, right? So this is a series of numbers, integers, right? Starting from 5, right? So we can't call it as a 10 factorial, right? I mean, if you look at it, it could become a 10 factorial, but there are few numbers are missing, right? So think about a way where you can convert this to a 10 factorial, because look at the last digit, right? It's 10. And look at the previous numbers, it's 9, then previous number, 8. So this will qualify to a factorial, but we need to do some modification to this, to the sequence, right? So how to do that? It's pretty straightforward, right? So think about it. So what all numbers we need, right, for 10 factorial? 1 times 2 times 3 times 4, right? Times 5 times 6 times 7 times 8 times 9 times 10, right? So we got this number, right? But we don't have this number, right? Let's say I use this number, right? But it has to come from somewhere, right? So what we're gonna do, we divide this by 1 times 2 times 3 times 4, right? It makes sense, right? You negate this from the denominator with the denominator, and so you will left with the same result where we started. But we can do something like this, right? It's pretty straightforward, because we wanted to make it to a 10 factorial. So the only way we can do to 10 factorial is to include 1, 2, 3, 4, 5 multiplication, and then divide it, right? So this will become something like 10 factorial, and at the bottom it will become 4 factorial. How cool is that, right? So we converted these numbers into factorial. This is how you do it. When you got a problem like this, right, you need to look at, first of all, the best way to look at it, look at the last digit, right, and look at the first digit, right? So if the first and last digit is a part of a factorial, you think it can form factorial, then extend instead of going to 11, 12, 13, we can't do that, right? Because it has to start from 1. So just have a look whether you can do something like that, right? So this is one of the approach you can do when you're trying to work out if a specific expression is a factorial or not, right? So that's one of the example, right? And so yeah, I mean that's the way you can work out. And so I hope that it's more clear for you guys. And when you get a problem like this, okay, let's do one more problem before I close this off, right? I just promise there won't be any more problem. Just one last problem. It's going to be a bit interesting. It's a bit different. You will find out what I mean by different. We're not playing with numbers here much. We're going to play with some kind of equations. Sound cool, right? So that I'll give you one more problem in your tool set. Problem solving skills in your tool set, I would say that. Okay, mathematics is fun, it's exciting, right? I mean, I don't know why people say it's too complicated, because everything in life is complicated, right? Life is not easy to live at first place, right? We got to do our chores, we have to sleep, we have to eat, we have to drink, we have to do a lot of stuff. It's a body activity. Mathematics is an exercise for your brain. That's how I look at it, right? So, all right, okay. Sorry, I digress. Okay, so we let's see. So we got equation something like this, let's say something n plus 1. Find the value of n, right? If n plus 2 factorial equals to 56 times n factorial, right? And n plus 1 factorial equals to 30 n minus 1 factorial, right? Now, you might wonder what I'm talking about, right? It's getting a bit complicated. You might think, oh, what is this guy talking about? Okay, all right. So let's start with one problem, right? So this one, okay. So n plus 2 factorial, right? You can write something like this. n plus 2 times n plus 1 times 1 n factorial equals to 56 n factorial. Because, imagine it is 6, for instance. 6 will become 5, right? So n plus 2 become n plus 2 minus 1. That's become n plus 1. Times n plus 1 will become n plus 1 minus 1. So that's become n factorial. So this, you can write it as something like n plus 2, right? N plus 1, right? Equals to 56, right? This equals to n squared plus 3n plus 2 equals to 56, right? And so we got something like this: n squared plus 3n equals to 54, right? This is something like, it's pretty straightforward. So, okay, now, all those people who've done algebra, right, you know how to solve this one. It's pretty straightforward. Let's use the algebra knowledge here. Can be written as n squared. Come on, hang on. N squared, right, plus 9n minus 6n, right, minus 9 times 6 equals to 0. So this equation will become exactly the same like this, right? So you solve this one, solve this equation, right? Sorry, this one, and you will get something similar result this way. So if you need to use your algebra skills here, right? So because 9 times 6, right? So obviously you got this one here, and then you got to use 3n, so 9n minus 6n, right? So that will become something like this. So you know what? so we're gonna forget about this for now. So I leave this for you as an exercise, right? To figure out this is factorial, right? So we need to find a value of n for this as well as for n. That's the problem we have, right? So I'm telling you how to do this one, and this is your exercise. You can work out now. So this will become something like n times n plus 9 minus 6n plus 9, right? It's pretty straightforward. Equals to 0. So this implies n plus 9, n minus 6 equal to 0. So that means n equals to 6 or n equals to minus 9. There you go. You found the value of n. So it's pretty straightforward. So similarly, you can use this equation as well to find. So we need to find the value of n, right, for both the case, right? So first equation, we have n plus 2 factorial equals to 56 n factorial, right? So n plus 2 factorial can be simplified as n plus 2 times n plus 1 times n, because we are going like, it's an equation, right? It's a formula what you have learned. So for instance, 6 factorial becomes 6 times 5 times 4 times 3 times 2 times 1, because we're subtracting 1 from the previous number, right? So exactly what we're doing here. So we got this and we substitute, and then we got an equation, right? We got a n squared equation. So n squared plus 3n plus 2 equals to 56. So now we got n squared plus 3n equals to 54. Now use your algebra knowledge, right? N squared plus, this can be split into following aspect of it, like n squared plus n9, n minus 6n equal minus 9 times 6. So similarly, you can solve this one to n plus 1 factorial equals to 30n minus 1 factorial. So this can be written as n plus 1 times, so you can n plus 1, then you can write it as times n factorial, right? And then equals to, on the other side, you can solve it. So try to see if you can solve this one, right? If not, just leave a comment in the below. I can help you solve it if you can't, right? So that's pretty much so yeah, so that's how you can do factorials, right? I hope you find some value out of the session. This is all I wanted to cover today. So we have looked at subtraction, we looked at addition, we looked at multiplication, we have looked at division. Now we have looked at it's a number chain where starting from 5 ending with 10, right, to see if we can convert that to factorials. We did that. Now we got an equation like n plus 2 factorial equals 56 n factorial. We have solved that equation to get the value of n. Pretty straightforward. Use your little bit of algebra knowledge from high school, right? So that helps to solve this equation, right? So this is interesting part of mathematics, right? You have a problem and you have a tool set, and you can use that tool set to use to solve a problem. So yeah, this is fun part, right? So yeah, probably you who are watching this, maybe one day you will solve the biggest problem of humanity's ever facing, right? You will be one of the person who will be able to solve, right? So I mean, I'm not saying that you will be able to go and do that by learning factorial. I'm saying it's a learning point. It's a starting point, right? Everything is a learning, right? So you might come across a time in your life where you might use factorial for something, you might use differentiation for something, you might use integration for something, right? You might use matrices for something, you might use trigonometry for something, right? So yeah, it's depending upon the problem you're trying to solve. So that's where the tool set comes into picture, right? You have to use the right tool set for the right problem. So right, cool. So that being said, I'm going to conclude this maths week. Thank you guys for attending this maths week. So I hope I give you some different perspective, a different way of doing things, right? If you find something a different way than I've taught, so I'm more than happy to hear your opinion on that. And so from next time, right, we're going to talk about programming week, because I wanted to jump into programming stuff. Then we're going to talk about arts, literature, music, philosophy, leadership, right? We're gonna cover different topics, right? So we'll have things for everyone, so don't worry about it. So we're gonna start with first programming language, JavaScript. So I'll try to wrap up the entire JavaScript. I'm not saying every part of JavaScript, but as much as I can in an hour. So that's the part of it. So please stay tuned if you're interested to learn JavaScript. Then we talk about C Sharp. Then we talk about probably other languages as well, right? So C++, maybe Java. We'll see, right? All right. That being said, greetings and ideas from New Zealand. Take care.